Hi everyone, and welcome to today's webinar on leveraging AWS to help build enterprise-level applications with OSSCube and AWS today. My name is Allegra Molitor, and I'll be introducing today's speakers. But first, let's go over a little housekeeping. First of all, if you have any questions throughout the webinar, feel free to enter them into the chat box on the side of the panel. We'll be sure to answer questions at the end of the webinar. Secondly, all attendees will receive an email with a link to today's recording, or you can visit our website at www.osscube.com and our recorded webinars section. And don't forget to like, link, or follow us on social media. Now, without further ado, I'd like to introduce to you today's speakers. First, we have Matt Moyer, who is a Customer Experience Manager from the BlueBook Building and Construction Network. He will be giving real-life examples of how OSSCube used AWS to help solve his specific business problems. Secondly, we have Rakesh Kumar joining us. He is an experienced software engineer and the VP of Technology at OSSCube. Rakesh will be giving more details about the project and the value that OSSCube brought. And finally, we have Mike Ruiz joining us from AWS. Mike is a seasoned solution architect at AWS and will be going into technical details of the different components around this. Now I'll go ahead and pass the ball to Matt.
Thank you, Allegra. I'd like to start off by helping everyone understand what the BlueBook Building and Construction Network does, and then we'll get into what we are currently accomplishing with the help of the OSSCube and Amazon teams. So as you can see from the slide in front of you, we serve the business-to-business construction industry. And this industry encompasses several types of companies and organizations. In a nutshell, it's every corporation, government institution, that is engaged in owning, maintaining, and building properties and infrastructure, the architects and engineers that design them, the general contractors, subcontract and maintain these properties, as well as the supply manufacturers. We provide information and solutions that help facilitate connections and communication inside of this industry. I'm going to go around clockwise. So that you understand where we came from directory publishing. So what we did, and over time, in the words of other people, the BlueBook regional construction database was the Bible of the construction industry. Inside of the BlueBook was every company engaged in the industry in that local or regional market, categorized based on their level of specialty. This provided us with several advantages as technology continued to grow. Because what we're sitting on is we're sitting on the know-how, the infrastructure to maintain and continually add millions of names in a database annually. The company itself is still an employee-owned organization, and we have an inside team that reaches out and qualifies this information on all of the companies, as well as all of the projects that these companies are engaged in. At the center of the construction industry is a project. So this industry communicates more so than every other industry because there has to be a team involved, and there has to be communication to a variety of different prospective clients. So we've also added over 250 feet to the street that go out every day and meet with all of these companies, find out about what projects are going on so that we can share and leverage that information. We do that through a few different ways. One of the ways is an application called BidScope, which is a project lead search engine. It enables our companies to very easily define what types of projects are right for their business, search, and then start pursuing those relationships. The other thing that we have is our database, so that even if it's outside of a specific project, we enable companies to communicate with one another and get qualification information. We represent that through a pro view. So another great advantage that this provides to us as an information company is not only do we have this great infrastructure and human resources of our own to go out and collect this information, but all of the members in the network are also self-contributing information about their business. And since we are also hosting that information, it gives us some great search capabilities, because we have so much structured data that we can reach into to provide the most relevant company for any particular need that a buyer may have. We've continually invested in technology across the board for both search and access to company and project information. Around that, we've built several workflow solutions: project management suites, takeoff and markup software. Really, we're focused on delivering any enhanced workflow products that help people communicate better with the companies they want to do business with and the projects that they are bidding or ultimately working on. So with all of these conditions being present, it led us to see another opportunity for a new workflow solution for this industry. We realized that we had a great opportunity to provide a CRM system that's built for the business-to-business construction industry. The construction industry sales process is very unique in that it is always centered around a project, which means that in order to win a job, in most cases, I have to bid to multiple prospective clients who are also trying to bid the job. It makes it nearly impossible to use other out-of-the-box CRM applications, which may be great applications, but like Salesforce and Dynamics, they're not built for that one-to-many relationship. So there are two things that we knew going into this. We knew going in that we wanted to deploy in Amazon. We've had great success working with Amazon in the past. And we weren't going to just suddenly decide that we were going to be masters of the CRM business, because of it wouldn't have been feasible and it would take us forever to build. But we had to maintain control to develop the types of workflows that would really work for all of the different types of companies in this business. So it became a no-brainer to go with Sugar. We signed an OEM agreement with Sugar CRM, which gave us the flexibility to accomplish everything we wanted from a in-app experience and still have the horsepower and the reliability technically behind us, so that we didn't have to maintain all of the core code and functionality. So ultimately what we developed, Project Pipeline. And Project Pipeline, to help you understand the scope and the magnitude changes we had to make, we did everything from tearing apart the opportunity management for Sugar to build in the one-to-many. And around there, without just doing a feature dump on you, there are so many unique workflows between a manufacturer or a subcontractor that we had to customize nearly every module significantly. We also looked at it and said, okay, we need to leverage incredible database of company information that we have. Because now for Project Pipeline users, they can utilize the BlueBook database to keep their prospect and client records up to date, and to also find new prospects. We also needed to integrate it with our database of project information so that very easily someone could find a project based off of their BlueBook program and get that into their workflow and work it as an opportunity. And this currently, we have a product that is being used from everyone from national suppliers with offices and salespeople all over the country to local, relatively small to medium-sized subcontracting businesses. The OSSCube team was instrumental in the success of this particular project. It's actually somewhat out of character for me to do a presentation like this. I'm hopeful, but I don't know how many people in the construction industry are going to see it. But I've been very happy to do it because the OSSCube team has been, in my opinion, the best vendor that I've worked with. I'll give you just a little anecdotal experience that kind of typifies the level of accountability and support that we've had. So early on in the process, we were still defining scope. And the team from OSS, it was Rakesh, also our rep, Vivek, came in. We locked them in a room with us and a couple members of our team. And for 3 days in that room, 12, 14 hours a day, no windows, we were just defining scope. Had a great set. We still had some work that was yet to get done. I had to attend a conference in San Francisco, and while I was over there, I found out that Rakesh found out that I was there. He happened to be doing business at the same time. So Rakesh finished business up. He came, found me at my hotel, and in this middle of the convention, when everyone else is more into their, we sat and we worked and polished this scope for another 2 or 3 hours. That's just a small example. That example is all coming from someone that has a leadership role in the organization. But I can say every level that I've touched, from QA, through the development team to project management, has been excellent. There have been several sprints that we got done, and overall I've had a very positive experience. And the same can be said at Amazon. I can't give you very many anecdotal issues because it's been very, very easy to work with. Everything has worked, and any time that I did reach out to the Amazon team, I was serviced in a very professional manner. So if you are in the construction industry and you're in the market for a CRM, please check out Project Pipeline. Before I go, let me turn it over to my friend and the man that helped me polish that scope in San Francisco.
Thank you, Matt, and hi, everyone. My name is Rakesh Kumar, and I'm going to talk about some of the application design and deployment challenges that we faced while working on Project Pipeline, and how did we overcome those challenges. As Matt outlined, other than customizing the application to cater to construction industry workflow, the requirement was also to build an application that can scale and support multiple clients and their users who subscribe to the application as a service. Every client who signs up for the Project Pipeline service receives their own instance and can independently manage their users, their leads, and proposal workflow. Each instance of the application talks to the BlueBook backend lead database through Web Services API and pulls the relevant leads as per lead preference set, and it also integrates with other third-party applications to support the proposal submission process. The application also allows subscribers to import lead data from other third-party lead sources, and this gives them flexibility to use the application as a central lead and proposal management system and be able to use other popular lead sources in the industry as well. Now, since the application integrates with multiple lead sources, we also needed to deal with the duplicate lead challenge. So we enhanced the search and deduplication functionality in Sugar to allow them to identify such duplicates and take different course of action, which can be either merging multiple leads into one or group them into one with multiple opportunities. The application also allowed for time-bound delivery of proposal, and we needed to create an effective queue management system to ensure that proposal timelines are met. Based on the assessment, it was identified that many contractors like to submit their bid as late as possible, closest to the deadline. So we needed to build a system that can effectively manage the surge of proposal submissions and ensure a timely delivery of the same to the target. So we used a third-party provider for the actual delivery of the proposal and built a queue management system to effectively manage the proposal queue. Sugar CRM Professional Edition was used as a base framework with a lot of customization to support the workflow for construction industry. Matt has already talked about the details of the customization done in Sugar CRM, so I will skip to the deployment challenges and what I'm going to talk about in the next slide and how did we address those challenges. When we started discussion on the deployment environment, the key question we needed to answer was whether to go with the existing non-cloud hosting provider or move to a cloud-based provider. At the application design phase, we did not know how fast the application will grow and the pace at which new clients will come on board. Now, just like most of the applications developed, I mean, we could have always guessed based on certain parameters, but more often than not, the reality turns out to be different. So we needed a platform in which we can start small and cater to the needs of initial customers. At the same time, based on the pace at which new customers sign up, we could scale and add more capacity. We also needed a platform that is highly available and allows for redundancy without significant investment. And most importantly, all this available through an automated self-detection based configuration. We needed a platform that can dynamically respond to the demands that users put on the application and take appropriate action, including automatically adding capacity. We wanted to avoid manual intervention as much as possible for obvious reasons. I mean, it's expensive, and the response time is driven by SLAs and on-call staff. So those challenges we didn't want to address in this project. When we consider all the parameters, AWS kind of just became a natural fit. And in the next slide, I'm going to talk about the advantages of going with AWS. AWS not only met all the criteria, it also provided services that we did not need initially, but gave us the flexibility and multiple options to consider for future application growth and capability planning. It gave us the flexibility we needed. We could start at any level and configure the infrastructure to respond on demand. AWS provided us with multiple options for the level of high availability and fault tolerance we needed, from having the deployment environment set up in a single zone within a region to cross-region deployment for highest level of availability. Now, just to give a quick overview on zones and regions, each AWS region is a separate geographical area, and within each region, there are multiple isolated locations known as availability zones. Although the availability zones are isolated, they are connected with each other through a low latency link, and depending on the level of high availability and fault tolerance required, deployment environment can be provisioned from single region, single zone based infrastructure for relatively lower availability requirement to multiple region, multiple zone for highest level of availability and fault tolerance requirement. We initially started with single region, single zone, and are currently on single region, multiple zone for both performance and scalability. Our current setup is totally automated to add new capacity if the demand on the deployment goes beyond the threshold, and is also automated to scale down when the demand goes back to normal. We currently have a CPU usage-based threshold setup, but the threshold can be set up based on other parameters as well, like disk read-write or network data transfer. In the next slide, I will talk about the AWS components and services we currently use. Most of you may already be aware of these components or services and may be using the same as well in your application deployment environment. So for benefit of those who are not fully aware, I will give a quick summary of these components. EC2 or the Elastic Compute Cloud is a web service that provides resizable compute capacity in the cloud. App servers or web servers are typically hosted on EC2 and can also be used as a database server, although AWS offers fully managed services called RDS for the same. Depending on the actual requirement, AWS offers a flexible option for instance types, starting from general purpose instance with SSD-backed storage to compute or memory optimized instances for computationally heavy CPU-bound or memory-bound operations. EC2 also allows the flexibility to reserve instances and provides significant saving on the hourly cost. So after initial on-demand setup and testing for a few weeks on the usage, we arrived at the optimal instance type that we could reserve and save on the hourly cost. So currently we are running on reserved instances on multiple availability zones. The next important component we use is RDS, which is Relational Database Service on AWS Cloud. We use MySQL multi-AZ RDS instance in our setup. Later in the webinar, later on, Mike is going to talk in detail about RDS. So I will move to the next component we use, which is S3, which stands for Simple Storage Service. Simple Storage Service is an object-based storage on the cloud. We use S3 to store all the documents uploaded in the application. S3 provides a low-cost, highly available, high-performing, secure, and extremely durable cloud-based storage. We also use the same for application snapshot backup. We use Elastic Load Balancer to distribute incoming application traffic across the 2 EC2 instances we have set up. And in addition to distributing the traffic, ELB also provides the much-needed automation to detect any node failure and divert traffic to the healthy instances. And in combination with auto-scaling, it provides the much-needed high-performance setup to meet the growing application demands. CloudWatch is the monitoring service that provides us the much-needed insight into cloud resource utilization and allows us to set alarms and notify right stakeholders if any threshold is breached. It allows us to react in a timely manner about any parameter that requires manual intervention to ensure the smooth running of the application. The next slide kind of puts it all together in form of a deployment architecture diagram. So here you see that we have 2 EC2 instances running in multiple availability zones with EBS volume for local data application file and instance store. Running behind a load balancer which distributes the traffic to both instances. Now, I did not talk about EBS in the previous slide, so just I'll touch upon that briefly. That EBS or Elastic Block Storage is a durable block level storage volume that can be attached to EC2 instances in the AWS cloud. Now, durability is the key phrase here. Local instance stores in EC2 are not persistent, and you lose data in the event that instance is stopped and started or terminated. EBS provides the persistence needed in such events. We have MySQL RDS multi-AZ instance type, as you see, and we currently have the setup in a single region, which has served the needs very well so far. And I mean, we have never had to face any outages so far, and we hope it continues the same. But like I said, that AWS provides the services to add additional regions in our deployment for higher availability. With this, I would like to invite Mike to take over from here and talk about the managed database services in detail. Mike, over to you.
Thanks, Rakesh. This is Mike Ruiz. I'm a solutions architect with Amazon Web Services, and today we're going to talk about an introduction to managed database services on AWS. Managed database services were an integral component of the OSSCube solution delivered for BlueBook. And why would they choose such a solution? As many of you probably know, database management on premises is very difficult. You have physical security and network concerns to deal with. You have to provision power and make sure that there's enough cooling available for the physical infrastructure. You need to rack and stack the infrastructure when it arrives. You can have lengthy hardware procurement and complicated hardware maintenance cycles. And then you must deal with operating system installation and patching. And that all sits underneath the actual task of installing the database, maintaining the database software stack with patching, backing up the database, making provisions for high availability and scaling, and then, of course, optimizing the application to properly use the database in the most efficient manner. With AWS, AWS handles all of the physical and operating system management for you. In addition, they handle all of the database software tasks as well, leaving the customer with the task that they're best suited to handle, which is properly optimizing the application for proper use of the database platform. AWS has a managed service for each major database type. Amazon DynamoDB is an excellent document key and value store, whereas Amazon ElastiCache is for in-memory caching using Memcached or Redis interfaces. And Amazon Redshift is a massively parallel processing data warehouse platform. Today we'll take a closer look at Amazon RDS, which offers a platform for a variety of different SQL database engines. Amazon RDS is a managed SQL service. Simple and fast to deploy. It's simple and fast to scale. AWS handles patching, backups, and replication for you. It's compatible with your application and offers MySQL, Oracle, Microsoft SQL Server, PostgreSQL, and a MySQL compatible engine developed by Amazon called Amazon Aurora. Amazon RDS offers fast and predictable performance, and there's no cost to get started. How does RDS deliver high performance? In two main ways. You have flexible storage options when provisioning storage on Amazon RDS. Two of the fastest are available using all SSD-backed storage. General purpose SSD storage is suitable for most workloads and provides 3 IOPS per provisioned gigabyte, with a burst capacity of up to 3,000 IOPS. If that's insufficient, you can choose provisioned IOPS, which offers very high predictable performance, up to 30,000 IOPS per instance. And you can scale the provisioned IOPS up and down online as needed by your application. In addition to the storage options, Amazon RDS offers a variety of flexible instance types, with instance sizes varying in capacity from a couple cores, from 2 cores, up to 32 cores and 244 gigabytes of RAM. Amazon RDS also automatically handles backups. Automated backups provisioned out of the box allow you to restore your database to a point in time and are enabled by default. You choose a retention period up to 35 days, and you don't pay for any backups up to 100% of provisioned storage. Of course, the customer may also provision manual snapshots. You can initiate them via the console or the API. These snapshots persist until you delete them. Can be stored in Amazon S3. You can associate various policies with the lifecycle of the backups. Finally, you can use the snapshots to build a new database instance from a snapshot when needed for recovery, or to instantiate dev, test, and staging installations, or to build an entirely new installation in another region. Amazon RDS allows you to select multi-AZ for increased availability and durability. With AWS, an availability zone is a physically distinct, independent set of infrastructure within an AWS region. Multiple AZs are always available per region. And with multi-AZ RDS operation, your database is synchronously replicated to another zone. Failover occurs automatically in response to the most important failure scenarios without user interaction. You can increase performance of RDS by adding read replicas at any time. This allows you to offload read traffic to managed read replicas, and you can create multiple read replicas to load share traffic. For Amazon Aurora, you can create up to 16 read replicas. You can promote read replicas to a primary on demand, and they're easy to add or remove. You see here an example of using the console on the right-hand side to create a read replica, promote read replicas once they are instantiated, and delete them whenever you wish. A similar operation using native MySQL is slightly more complicated. This feature is available with Amazon RDS for MySQL, Aurora, and PostgreSQL. With RDS, you can choose cross-region snapshots for even greater durability and ease of migration. For instance, if my database resides in US East, I can make a snapshot and place it in the Tokyo region. This allows me to create a warm standby for disaster recovery. The only cost I pay for is the storage cost for the snapshot itself. And I can use that snapshot at any time as a base for a migration or to instantiate an entirely new RDS installation in a different region. How can I scale with Amazon RDS? You can simply select different instance types. This can incur a short downtime, but as your database needs scale up or down, you can select the instance type that's most appropriate for the workload. You can scale up your storage with a few clicks, adding storage online, and with provisioned IOPS, you can change the number of IOPS available for your instance. Again, in accordance with your needs. As your read traffic varies, you can add or remove read replicas on demand. And finally, you can add a cache layer in front of Amazon RDS if appropriate. You can use the managed service Elasticache to add a Memcached or Redis installation, or you can use your favorite off-the-shelf cache, either self-managed in Amazon EC2 or by using one of our partners who provide that service. Finally, let's take a look at how Amazon RDS Billing works. This is an example of a monthly bill. In this example, we show a single AZ RDS installation using the MySQL engine in the US West region using a DB M3 extra large instance type. Those are the four main considerations: instance type, engine type, region, and single or multi-AZ installation. In this case, an M3 extra large provides four virtual CPUs, 15 gigabytes of RAM. In addition to the instance type, we're provisioning 100 gigabytes of general purpose SSD storage. For the instance and engine, 720 hours at 37 cents, plus 100 gigabytes of storage at 11.5 cents, equals $279.05 per month. Again, you pay for what you use. If you shut this instance type down halfway through the month, you would pay half of this cost. So the pricing example assumes DB instances accessed only from Amazon EC2. Amazon access from elsewhere might incur a transit charge. For further details, see RDS pricing at the link at the bottom of the page. So a quick review, the benefits of using AWS managed database services. AWS handles installs, patching, restarts, all of the infrastructure concerns in running a database. It's easy to scale, allowing you to grow as you need. You pay for only what you use with no upfront cost. And Amazon RDS is designed for use with other AWS services. Thank you very much.
And there we have it. Thank you to everyone for attending, and thank you to Rakesh, Matt, and Mike for being here today to talk to us about AWS and the BlueBook Building and Construction Network project. If you have any questions, feel free to reach out to anyone with their information here on the slide. You can also visit OSSCube.com, thebluebook.com, and AWS.amazon.com. Thanks, and have a great day.